So a rational number is anything that can be written as a fraction. So what we're going to look at now is a few examples of rational numbers to see if we can see what does it mean for decimals. So the first one is 5 divided by 1 is 5, so which is just an integer or a whole number or a natural number. So all integers, whole numbers, and natural numbers are rational numbers. And the reason is because you can always just put it over 1. So if it's -7 over 1 is -7. -11 over 1 is -11, 25 over 1 is 25. So you can write absolutely any integer, natural number, or whole number as a fraction, so it has to be a rational number. Now let's look at 11 divided by 8. I'm just going to get out the calculator. 11 over 8 is 1.375. So 1.375 is a decimal that ends or terminates. So we call this a terminating decimal number. And the thing about any terminating decimal number, it's actually really easy to write it as a fraction. All you do is take the number without a decimal and put it over a 1 with however many decimal places there are, that many zeros. So because 375 is 3 numbers, I put it over 3 zeros. If it was 1.2, then I'd go 12 over 10, just 1 0. So it's always easy to change any terminating decimal into a fraction. To look at -23 over 99, we'll go to the calculator again, and I get -0.23232323, so it's basically a repeating decimal. So this means that repeating decimals are also rational numbers. So basically what happens, anytime if you want to change a repeating decimal to a fraction, it's just however many numbers are repeating, that's how many 9s you put it over. So 0.7 repeaters, 7 is just one number repeating, so I put it over 9. 0.123 repeating, well, 3 numbers repeating, so I'll put it over 3 9s. And we can go to a calculator and check this out, and you can see that 7 divided by 9 is 0.77777. 123 over 9 is 0.123, All right, to get a decimal definition of a rational number now, we're going to put this all together. So the first thing to notice is that 5 we'll consider a terminating decimal number. So it doesn't keep going forever, it just stops, so we'll say it terminates. So it's any terminating decimal number or a repeating decimal number. So anything as long as it ends or it's a repeating decimal, we can write it as a fraction, and those are rational numbers. So from this, we'll just kind of look at the opposite, and we get a decimal definition of what an irrational number is. So it is, if it's any terminating decimal, well then irrational's got to be non-terminating decimal. So it's got to go forever, but a rational number repeats, so then an irrational number can't repeat. So it's got to be a non-terminating, non-repeating decimal number. The most famous example of this is pi. And here is what pi looks like, and it's huge, and you can start looking at it, and there are places in pi where people thought it repeated, but it never does actually. Okay, a couple other famous examples of irrational numbers are e and root 2. So e is Euler's number, and it's 2.7182, etc., etc., etc. Root 2 is 1.414, etc., etc. What's interesting about the root is actually any root of a non-perfect square or perfect cube or whatever is a irrational number. So square root of 25, well, square root of 25 is actually just 5, so it's a whole number. But square root of 24, if 24 I can't take the square root of, if you can't take the square root of it easily, it's an irrational number. Okay, so now thinking about all the number sets, basically your natural numbers, whole numbers, integers are all considered rational numbers, plus there's more fractions. The irrational numbers are another set. If you put the rational numbers and the irrational numbers together as one set, we call those the real numbers. And we're not going to talk about what's the opposite of the real numbers right now.